Hi everybody. Do you remember this? And that. And the variac. And some stuff under there. Some switches. And a bunch of electronics down here. I'm gonna change that. I'm gonna take away all of these stuff. That's up here. This is the backup part. That and that. And some inverters. And that's a 24 volt power supply. That goes to the 24 pin connectors. That's one there. The other one is on the side. And here's some contactors and lots of dangerous things here. Here we get that's 240 volts, 230 volts. And this is a bed. And if you get your foot in there, you will quickly take it away from there because you will get a shock, of course. And what's dangerously is when the foot is there and you suddenly touch the radiator. That's ground. It's 240 volts, so that will quickly wake you up or even make your sleep longer. So I'm gonna take away all of this scrap, put it in this cabinet here, and I'm going to get another cabinet like this, put inverters in it, and this cabinet here will go on that, down there. I'm going to put that on this, so two on each other, and I'm going to put a smaller one, smaller than this, with inverters, just inverters. Not that. Just inverters in it. Here. This is actually not connected anywhere. This one goes up to a contactor, and after the contactor it comes this. And yes, why is my computer on? It's because I accidentally screwed in that screw, and the inverter came on and gives the computer backup power. It's actually not connected in the wall, or it actually is connected, but there's a mains input and this. So if I turn off the inverter, the computer will turn off. Don't believe me? Yes. Now you do. Yes. I'm gonna take away this stuff. Here's the controller for the 24 pin connectors. Here we got it. I wonder what the... Oh! Something is loose in here. Is it this? Oh yes, it was. Yes. Need to be careful when I cut these things. There's no fuse on it, and it's connected to these big batteries. So when something happens, I think I will burn up something. Here's the battery connection, and this is why you need to be careful. And why does it spark so small sparks? Because the wires are so thin. And if I short it out, the wires will burn. And here's the fuses. Yes, here's the fuses. Lots of wires. It's a delay. 300 watt. Doesn't look so good. There's 1000 watt. Here's the last inverter. Here's the other inverters. Lots of scrap. Lots of dust here. Oh, look at that. Wires. Lots of it. Let's take all that shit away. Amp-meter is still connected anyway. But not the voltmeter. The voltmeter is here. And the amp-meter for the inverter and the voltmeter wasn't connected anywhere. Defibrillator. The cabinet is gone. It's over there. Look at this. Bird's nest. Lots of bloody wires. Some juice in that. It's some juice in it. Better not touch it. Right, 4 pins are not connected in there. Looks awful. Same under there. Look at that. There's a ballast. Oh, so dusty. Everything. It's juice there. Ammeter. Now the UPS controller is gone. There it is. Now you can see how shitty it is. Yes, I need to cut the clock wires. Clock wires was some wires which was going into that UPS controller. That clock wire I connected to one of these sockets. Where's the clock? Where's the clock? I lost it. Yes, but anyway, the clock's plugged into that. That one was always getting 240 volts. Yes, a bit more stuff now. Still lots of scrap. And I found something interesting. There's a controller wire which was going to the connectors. Those. And this still works. Nice. Oh, it's time to take this scrap out. But before that, I need to remove the bed. Oh. Still got juice in that. Don't believe me? Yes, I need to remove that. Oh, that bloody computer is in the way. I can't reach in there. There's my hook. Fucking hell. Lots of dust. Dusted everything. Now the bed is lifted up. There's a big wire for the outdoor, and that's the new control wire I'm going to use. Yes, that's going to the 24-pin connector. And this one goes to switches, B switches, bed switches maybe, the switches which are coming here soon. And here we got the front switch, that's these switches that will be connected into that. Yes, the bed is out, and yes, you can see how it looks like now. Nothing connected to it. Yes, nothing connected to it. That's RCD. That's just for your computer. Don't want to shut it down. Need it. Yeah, so that's the new thing. I need to put some rails on that. And that will go inside that one. Yes. Lots of space. It'll look much better than that. Yes. I think I need to put that on this. No. I'm gonna put that on this. Much better. Yes, and the contactors. Some contactors. I need another one of these. These are 24, and that one and that one are 240. So that's contactors are for the 24 pin connectors. These ones. So I put the plug in it, we turn on that contactor. And when that contactor turns on, the other one turns on. There will be 3 of these. That's one of them. It's another one. Just here, just there. And the third one on that. So that would be nice. That antenna versus the CRT. And it's time to screw it off. Now the table is down and you can see how messy that is. And after 5 minutes, nothing left. Under the computer desk. Lots of crap. It looks awful here. That's in place, but nothing inside it. Nothing is still connected. Yeah, there's lots of other scrap as well. And I begin to build this controller board. This controller board will go into that. VFD. As a 3-phase output, I want to connect it into a fuse. 3-phase fuse. 24 volt power supplies, 2 of them. Input contactor, that will be the main contactor. Relays. Impulse relays. Circuit breakers. More relays. These are 230 volts. These are 24 volts. That's the main contactor. That's the variac contactor. And that will be the variac fuse. And here we got 3 identical modules. I don't include these RCDs. But that one looks identical. They are for the 24 pin connectors. There will be 3 of them. And now lots of shit. Lots of stuff to do on this board. Oh, and now it's time for drive wire, control wire. Look at that, pretty fat. It's 5 double pairs No, it's 5 pairs, I mean 10, and each one 8. So what do we get? 80? No. Yes, 80. Lots of cables. One third of the job is done and lots left. Lots of work left. There's the wires, which are going to all the loads. Here they come. Oh, they didn't reach all the way down here, so I need to make them a bit longer. And yes, I was in the scrapyard again. It's not like a normal scrapyard. They just throw everything they want, and it's just for me to go there and take what I want. So I found this one. It's pretty good for the inverters. It's fat, extremely fat, not so extremely, but 50 square millimeters, 25 meters of it. That's a date. So pretty nice. Maximum 75 volt DC. Not more than 12, which is going into this. Or 14 if I had a charger on. Let's see how heavy it is. $13.2 kilograms. So pretty heavy stuff. So pretty good for the inverters and batteries. And there we got in isolation transformers. These are awesome. That's for a variac. That one will be just for 1 or 2 sockets. And this big one, this is awesome. Got a 240 volt here. And yes, each, there are 2 of them. One 150 volts, 15 volts in each. So I connected 2 of them in series to get 150 volt, 15 volts on each. That's 230 volts. And the outputs are 240. I connect them like that. I can bridge them. They're here. I can bridge that to get 440 volts. And that just there is one. That's 110, 115, and the other one. That one is 240. That's 115, 240, 240, 240. Bridge them. 440 volts. And that's 230 volts in. Time for the boring part. That wire is going to be the 5-pin connector. That one a bit too short. So I need to extend that with this. That one. And the boring part is that's not the only one which is a bit too short. All of the wires are a bit short. They're all too short. So I need to solder that. Messy. There you see how many wires there are. Now it's time to solder that with this. So got this thin wire, solder wire. No, That's just for electronics. But with power electronics like this, you need to use a fat one. Much better. One done. Lots left. Yes, it's done now. There was one. And there was the other one. These two goes all the way down here. These two. And there's lots of wires left to extend. This isolation transformer one. This goes to that one. Verek. Don't know what to use that for. I use that instead of that. That was much bigger. Lots of wires to plug in. Yes, and here we got the backup panel. No, not backup cabinet. The new one, not connected yet. There's connector blocks from batteries, negative, positive, 12 volts. There's fuses, nothing in them. There's two inverters. And here's the wire from the batteries. There's a negative. I don't have any red tape on this, but this is the positive one. Here fat is 50 square millimeters. And there they go. Lots of fat wiring. Lots of them. And that hole is exactly 50 square millimeters. Just fits perfectly. Yes, and here's the backup cabinet again. The wires are connected in. There's the inverters. That's 6 square millimeters. That's 15 square millimeters. There's nothing confuses yet. But it looks much better than the old one. I need to be a bit careful with that. Yes, the best thing with this backup cabinet is that it's portable. You can just disconnect these two and these ones and just take it with you anywhere else. But it will not work if it's 110 volts. But it's a 240 volt, 230 volt cabinet. That will not work. Here's the voltage out. It's 5 wires, one's ground, 2 for inverter 1, 2 for inverter 2. Here's the controlling wires to turn the inverters on and off and measure temperature and yes, stuff like that. Then we got the charger. There's fuses. Looks pretty nice. Oh, the Verek is opened. 3-phase VFD. It's in place. Let's have a look inside it. Much better. There's inverters. That's not connected. Much better than the old one. Best thing with this is that it's portable. You just need to disconnect these two and the wires on the back. And then you're gonna connect that to that one, and you will get a UPS. That panel is almost done, and yes, it's time to put another panel down here with all the amp meters and watt hour meters and that sort of stuff. Here's all the meters, some switches. That's 2 AMPMETERs, 2 voltmeters, 1 voltmeter for the VAREC and for the mains and all of that. We'll go on that one. And so on this one, that will go under here. There's all wire switches which are going to be connected to it. There's some signal ones. It's for the inverters. This one goes to that. Both of them goes into that one. So it's for the mains. And that short one is to the VFD. And here it is, in its place. At last. Now we got the hard part. To connect those. It's in place. That one. Jesus. There's some shit left. Yes, we'll do that one. 2 ballasts, MOTs and sockets for oscilloscopes and those stuff which are going to come up here. Nice. No, they're not connected anywhere. There's a battery amp meter, voltmeter. Yes. It's time to connect everything. It's a bit of work. That's the paper. The numbers is those, or are those. Lots of them. Now the power wires are done. The signal wires are left. And here's the final result. It's in place, all the wires are connected in, lots of them are behind this white thing. And there's the signal wires. All signal wires, without the 2 signal wires for the FET switches and for the 24-pin connectors. And the rest of it works extremely well. Yes, it had some faults, but quick repairable and has been runs extremely good. I just need 2 12-volt batteries for give 24 volts if the power gets off for these time relays. They're extremely important because it's that which switches the inverters. And yes, everything else works pretty good. And there you got a nice label, centralen spänningssatt, and that means there's a voltage in this switchboard. Yes, and here you got a nice thing. This is a node stop or emergency stop. Turns off everything. Of course, not the computer. Has a 5-pin connector. It's actually 3-phase contact. And yes, here's the wires. And there we got how they're connected. And that schematic is how this thing looks like. But that's not the whole schematic for it. This thing is way more than that. Insulators. And yes, there was another 5-pin connector, a 3-phase output. And that's for a VFD. That's still not connected in. But all the important things are connected in. We got voltage. We got kilowatt hours. And we got this. There's lots of scrap in it. But that's too important. Inverters, and that's just not connected anywhere. The rest of them scrap. There's some fuses if something blows. There's a current oscilloscope, homemade function generator, normal oscilloscope, frequency counter. I'm going to connect these two in as well. Temperature meters. And that's a various frequency drive. These are nice. And yes, of course, the most important thing, the variac. Yes, it's an isolation transformer. And I got another nice isolation transformer, and that's that which is connected to this one. It gives out 440 volts. I'll try to blow some stuff up with it. And as you can see, it's a 32 amp variation of the plug or socket I mean. And that's a 16 amp. So of course this is much smaller, that's much bigger. So I can't actually connect that into that one. I have another connector for that. And yes, let's turn it on. See what it says. That's on. Let's see what happens. This time really got on. The contactor flew in. And yes, that's grid available. And it is. And still, that's the UPS contactors or computer contactors. Everything goes on UPS power or backup power. And yes, this one will be connected to bed switches and some other switches. It's impulse relay. Just push it, it turns on, push it, turns off. But I'm not going to turn on the computer yet. And yes, let's push the node stop in, like that. And that's for the main contactor, that's for the variac. That one is for the 440 volts. That one is for that one. And these two are for that socket and that socket. So main contactor, yes, just a relay, nothing else. That's this relay, and that's a contactor, and it did not go in because the node stop is pushed in. So I'm gonna release the node stop and let's see what happens. It turns on. Let's turn on the variac. That's a variac contactor, it's in, latched. And let's crank up the voltage. That's the variac voltmeter, and that's the AMPMETER for everything. Yes, as it pulls a bit of amps when I crank it up, because this is connected to isolation transformer, of course. That's important. And yes, that's the AMPMETER for the computer and UPS powered stuff. And UPS powered things are these, that one, and the computer, of course. So let's turn on the inverters. And yes, it's going to latch, I think. Yes, it's going to latch. No, nothing will happen. Yes, it's on. Frankenstein switch, of course. 27 volts, that's amp battery voltage. And let's turn on the inverter. Yes, the computer turned on, as you can see, and how many amps pulls. Of course, it's off grid, so if you don't believe me, it's off. Grid voltage, watt hour meter, everything off. So yes, I will turn on it again, of course. Yes, that's inverter 1. That's fault. That means if a power cut comes, the inverter 1 is of course on 24/7, and when it's a power fault, the other inverter, the 1000 watt, will turn on after 30 seconds. And within 30 seconds, this light will light up. And of course, nothing will happen because the other inverter is, of course, off. I shall switch over there. You can see there, this last one. And now, that one is on. But nothing happens. So turn off this. The middle one is for the transformers. That was a maneuver voltage, and these two are for the. One of them is for the all the outputs, and the other one is for the UPS outputs. So I will disconnect all of them. As you can see, that's for inverter, that's for the contactor. Inverter on. Yes, as you can see, that's unflowed in, and that's turned off. That's how it works. And of course the grid available was not connected all the way in. No, that's for the main contactor. That's the grid, that's the main contactor. Or that contactor actually. So this. I don't know why that happens. It's kind of weird. I think that's because it gets back voltage. Because it's AC. It actually will operate on DC, these things. So let's turn the power back. It's a bit hard, but I will try without breaking or disconnecting the computer with this. Yes, and this is a bit bad because, of course, this one is off. So as you can see, it's turned off. So it works good, no problem with it. But let's try the node stop again. Yes, that works. And as the power supply is back here, this switch is for a power supply, and as you can see in the AMPMETER. Now, of course, why did that happen? Because the node stop is connected in. Let's see again. Yes, power supply is on, and now that switch is a trigger. So now it gives out 24 volts out of that. But there's no indicator lights for it, which is not so good. But nearly everything works. That's dangerous. I need to have some plastic around it. And everything will be ready to go. And all this took about 2 months. Bit annoying, lot of time for it. But now it's done, and it's time to do some more experiments. More power. And another thing, all of these is 3 variacs inside this, 3 phase, and I connected them in parallel. So I pull out nearly 30 watts, volt, 30 amps I mean. So that's the only thing. Thanks for watching.